This is section 5.1. We're talking about the mid-segment theorem and coordinate proof. We're going to briefly talk about mid-segments because most of this would be about coordinate proof. If you are from the honors class, that is. If you're from the regular class, non-honors, then this is mainly about mid-segments because we are not covering coordinate proof. So, starting with what a mid-segment is. It's a segment that connects the two midpoints of two sides of a triangle. So for example, down here, if we were to say that D and E were midpoints, we know that because it divides the sides into two congruent halves. And so this segment DE is our mid-segment. So it connects two midpoints of two sides of a triangle. Certain properties that go along with it are that the mid-segment is parallel to the side that's across from it. So these two sides are parallel. And we also know that the length of the mid-segment is 1/2 the length of whatever it's across from. So in this case, DE is half the length of AC. And both of those particular facts are given down here. That is your mid-segment theorem. So, to do a couple of quick problems with your mid-segment theorem, looking at these three triangles, we know that DE is a mid-segment of triangle ABC. Find the value of x. Well, if this is the mid-segment, then it's half the length of this side. So in this case, 7 equals half the length of x. So if we multiply both sides by 2, so the 1/2 and the 2 cancel, we end up with x is 14. You could have also done mental math like we will do for the rest of them, for the most part, and that would be fine. For number 2, this is the mid-segment, so these are midpoints, which means that these two sides are congruent. So in this case, x simply equals 8. Again, because this is the mid-segment, so E is a midpoint, so these two halves are equal, so x equals 8. And for our last one, x is half of 34, so x is 17. Again, because this is a mid-segment, so it's half the length of whatever it's across from, so x is half of 34, which gives us 17. So that's your mid-segment. For the regular class, you can feel free to stop the video. Those are a couple of quick examples. Mid-segment is very basic. For honors, we're going to continue on with coordinate proof. So, first it says place a figure in a coordinate plane. We're going to place each figure in a coordinate plane in a way that is convenient for finding side lengths. Assign coordinates to each vertex. So starting with a rectangle, which we'll do in green for now. So placing this conveniently, we always use our origin because we know the coordinates are 0, 0. If it's a rectangle, we know we form a right angle. So let's continue up on our y-axis to form a right angle here. And we don't know how far up we're moving, so I'm going to go ahead and call that h. But we do know we've gone left to right 0. So we can say that's 0, h. We don't know how high we went, but we know we didn't go left or right at all. Again, it's a rectangle, so we can also form a side down here of a different length. We'll call it k. We haven't gone up or down at all, so that's 0. And we're going to connect these two sides here, because this should be a right angle, so these should all be right angles. And we know we went over k, and we're up here at h. So that's k, h. We choose variables like k and h instead of x and y so we don't confuse with the x and y axis. So there's our conveniently located rectangle in the coordinate plane. And we use variable coordinates because we're going to use those in proofs. When we're proving something, we're always talking about in general. We're not talking about an example. If you were to give an example does not mean the same thing as proving something. So instead of giving an example, we use variable coordinates to talk about the general case and not a specific example with numbers. Let's go ahead and place a scalene triangle here. I'll do that in a different color. I'll do that red. And I'm again going to use my origin at 0, 0. It says scalene. It doesn't say that it can't be a right triangle. So I'm going to make this a right triangle and go up and go over. Connected. It is still scalene, but it's a right triangle. Here I went up some unknown amount h. Here I went over some unknown amount k, but I haven't gone up or down at all, so I can still say 0. So there's my conveniently located scalene triangle in the coordinate plane with my variable coordinates. But enough about this. Let's actually prove something with it so this makes sense as to why we give variable coordinates. We're going to place an isosceles right triangle in the coordinate plane, then find the length of the hypotenuse and the coordinates of its midpoint, of the hypotenuse's midpoint. So, isosceles right triangle. So again, I'm going to place one point at the origin. If it's isosceles, I'm going to go up the same amount of units that I'm going left and right. And since it's a right triangle, I'm going to use my x and y axis, which are perpendicular, to have a right angle. And then let me draw my hypotenuse here. So here I'm going up some unknown amount. I will again call it k. But since this is isosceles, I'm also going over k. So it's the same distance. I'm going up k units and right k units. So in this case, they're going to be the same length. It's just like saying that I'm going up 7, so this is 7, and right 7, so this is 7, except we're not using a number like 7, we're using a variable k. So we're going to find the length of the hypotenuse and the coordinates of its midpoint. Well, to find the length of our hypotenuse, we're going to use our good old distance formula here. Distance formula. And when we use our 2 points, I usually like to label them like you know. x1, y1, x2, and y2. And when I plug those in, y2 minus y1 is 0 minus k. x2 minus x1 is k minus 0. And if I simplify this, 0 minus k is simply negative k. Keep it in parentheses. K minus 0 is simply k. Keep it in parentheses. And then, I can't choose a color. Negative k squared is equivalent to negative k times negative k, which gives you positive k to the second. And then I still have k to the second over here. K times k is k squared. And I can combine like terms to have 2k to the second. Now here's where what you learned in Algebra 1 becomes very important. If I'm multiplying here, I can give each of these guys their own square root. Split them apart. But a root, a square root, and a square will cancel. So I just have k. But it's proper form to put the k in front, because whatever is not underneath the square root should be placed in front so that you don't confuse it with being underneath. So in this case, the length is going to be k root 2. Now we have to find the coordinates of its midpoint. So I'm going to erase this over here, so if you're not finished writing it, go ahead and pause it. But I'm going to go ahead and erase it. And I'm going to find the coordinates of its midpoint. Well, the midpoint formula is you add your x's, divide by 2, add your y's and divide by 2. Yes, that's a y. And we already labeled our points for finding length, so our x's are 0 and k. Same thing with our y's, we have k and 0. And if I add 0 plus k, I still just have k, so I can really just erase that 0. And if I have k plus 0, it's still the same as just k. And I can't simplify anymore, so that is actually going to be my coordinate pair, my midpoint. K over 2, comma, k over 2. So our midpoint here, somewhere here, would be k over 2 and k over 2. Now we use these sort of things in proof type questions, which are on your assignment for this particular section, and that will give you a better understanding as to why this is so important. Let's do one last example. Graph these points in the coordinate plane. Is it a right triangle? Find the side lengths and coordinates of the midpoint of each side. So for the sake of the video, I'm only going to do a couple of these. I'll find the side length of one side and the coordinate of the midpoint of one side. Or actually, better yet, I'm not going to worry about the second part because we already did one like that in class. So I'm just going to find out if it's a right triangle or not. So point O is at the origin. I'm going to skip over to point J because I have a 0, so I know it's on one of my two axes. So I'm over at some point J, M, comma 0, and that's point J. And then I know that H is over at M as well, but it's up some unknown value N. And then I can connect my sides to form my triangle. The question is this a right triangle? Well, if it's a right triangle, that means that it needs to have a right angle. If it has a right angle, that means two of the sides are perpendicular. So I need to find if two of these sides are perpendicular by comparing their slopes, because we know that perpendicular lines have opposite reciprocal slopes. Well, out of these three angles, the only one that appears like it might be a right angle is this angle formed here, which is formed by the OJ and HJ. So I'm going to find the slope of OJ and the slope of HJ and see if they're opposite reciprocals. Well, for OJ, I'm on the horizontal x-axis, so I know my slope is going to be 0 because it's horizontal. So I can skip that part. Well, this isn't on an axis, so let's make sure that it's vertical, so that it's going to be undefined. You can notice this because our x-coordinates are the same, so we haven't moved left or right at all, so our run should be 0, which means this is undefined. If I were to work this out, if I took my slope formula, just for illustration's sake, y2 minus y1 is 0 minus n, and x2 minus x1 is m minus itself. Well, this ends up being a negative n over 0, which is undefined. Since a slope of 0 and a slope of undefined are considered opposite reciprocals or perpendicular, we can say that yes, this is a right. That's going to look bad because I was going to write my triangle symbol. That's a right triangle because opposite reciprocals show that we have perpendicular lines, which means we have a right angle. So we just basically showed that this is a right angle. So that's a brief run through of coordinate proof. You'll see these come up time and again. It's very important to be familiar with this because it helps you when you get to Algebra 2 trig, when you're graphing trigonometric functions, and it helps you when you talk about conic sections in pre-calculus. So I hope this video was helpful and that the assignment goes more smoothly.